Hi everybody, I'm Vivien Lecoustre. I am a PhD student in fire protection engineering for 2 years. This is my last year of studies. Let me show you a bit of my work. I'm working on numerical simulation on spherical diffusion flame. First, what is a spherical diffusion flame? Let me show you a video which had been recorded a few years ago at the NASA plane drop tower facilities. Have you seen it? This is a flame, and this is a kind of experiment that he did. How to perform this kind of experiment? You have microgravity on a space shuttle or International Space Station, but you can also recreate it on Earth using a drop tower. It's like a huge tower, you climb it with your apparatus, and you just drop the apparatus. The apparatus will fall for a few seconds, but during the fall, all the conditions are the same than in space. We use microgravity in order to simplify the problem, in order to investigate characteristics of some flames. And in my case, we are investigating soot formation on the spherical diffusion flame. Let me show you a picture of this flame. So this is a picture actually coming from the video and other experiments that look like the experiment that you saw. There is few features of this flame. So first here you can see this is a spherical burner, which is very small actually, a few centimeters. And then we have this nice blue spherical flame, you can see here. This is the part where the temperature are the highest. Between the burner and the flame, we have those orange-yellow particles which emits light, and this is soot. This is the same kind of compound that you can see in the candle flame that emits yellow light. My goal is to investigate numerically those flames which have been characterized experimentally, and I do that using a code and using my computer. So my job is I take the conditions which have been which are coming from the experiment, and then I put them in an input file. I run the code, and based on that, the code will give me a solution file where I will investigate parameters of flame such as temperature, species concentration, and time of mixing. Here, for example, you have the temperature profile of a flame, where here you have the temperature, and here you have the radius starting from the center of the burner. And as you can see that as we get closer to the flame, remember this, which is this blue part, the temperature gets higher and then after decrease. With my code actually I can investigate all those criteria, and then after to get some formulation and to raise some critical characteristic for the formation of soot. And this actually has a huge impact. First, it has impact for fire protection within the spacecraft, because the fire doesn't behave the same in space than it behaves on Earth. Also, it has some importance for soot formation, to reduce the formation of soot within like engine in your car or aircraft. And this is what I like with the job. It has very useful consequences